Okay, so we just started number 2 on the last end of the last video, and number 2 was an acidic tin 2 chloride solution. Okay, and so we have H positive ions, SN 2 positive ions, Cl negative ions, and water. We know water is both an OA and an RA. We know from other ones we've done that Cl is an RA on its own, but it's also an RA when it's linked with the water. We know H positive is an OA, and it's the first time, I think, that we're using SN2 positive, but we have talked about it already. We talked about the fact that it shows up on both sides of the equation. Here as an OA going to SN solid, and up here as an RA going to SN4 positive. So SN is both an OA and an RA. So now you need to figure out which one is the strongest. For the oxidizing agents, it's going to be the one I can never find because I never know when I set this down in front of me what part of the chart I'm on. It's the H positive. So it should be above this. There it is, H positive, because SN is below it. Okay, and the water is way below it. For the reducing agent, it is going to be the SN2 positive because it's here. The Cl, remember, is way up there, and the water's way up there. Okay, so our two half reactions. So this is going to be SO, whoops, off the edge of the paper, SOA, and this one's going to be SRA. So it's going to be 2H positive aqueous plus 2 electrons going to H2 gas for our OA. And for our RA, be careful and make sure you pick the right one. It's the SN2 positive on the right-hand side going to SN4 positive, okay? So going to SN4 positive, aqueous plus 2 electrons. These are already balanced, don't need to multiply by anything, so you will have 2H positive aqueous plus SN2 positive aqueous going to H2 positive, or H2 not positive, plus H2 gas plus SN4 positive aqueous. Last step, find out if it's spontaneous or not. So here I go looking for the H again. I should really just note where it is, but it's because when I put the sheet down, I can't tell how close or how far I am from the bottom on the screen. So my SN2 positive is here, and my H is here. So the OA is below the RA. It is non-spontaneous. Non-spawn. All right, number 3 says, what is the most likely redox reaction when iron metal is placed in copper 2 sulfate solution? So Fe solid, Cu2 positive aqueous, sulfate with an A, so SO42 negative aqueous solution, H2O liquid. All right. Fe solid. Okay, well, let's do the one we know. We know this is OA and this is RA. We did do SO4 before. I'm not sure if you remembered, but we found it on the OA side. Linked with water. Must be further down, linked with water. There it is, linked with water. I was going to say, can't use the one that's linked with H positive because we don't have it. We're looking for Cu2 positive. It is also an OA, and Fe solid is going to be an RA. Okay, So Ra, OA, oops, I just linked that on the wrong side, OA. Okay, you know it'll bother me if I leave it there. All right, so then which one is the strongest? When you check the chart between the two OAs, the SO4 linked with water is right down here. The copper is up there, so it's definitely the copper. And then when we look at which one is the lowest on the reactant side, the iron solid is down here and the oxygen is way up there, so it's definitely the iron. Okay, so this is the Ra and this is the OA. All right, so Cu, 2 positive aqueous, and again you can write this right off the chart. 2 negative is going to Cu solid, and then Fe solid is going to Fe2 positive aqueous plus 2 electrons. It is already balanced, so we can just add them together, and we will have Cu2 positive aqueous plus Fe solid going to Cu solid plus Fe2 positive aqueous. That would be a single replacement reaction if you were naming it chemistry-wise. Then you go back and check to see which one's higher. So our Cu was up here, our Fe was down here. The OA is above the Ra. This is spontaneous. All right, one more set to go for today. Okay.